Don't be a baby.
How am I being a baby? I literally grabbed it off my desk and set it in there without making that much noise. That's what I was trying to do.
You're like my mom when she tries to talk, like when she mocks you. It's like, no,
That's
I
why
don't
parents
sound
are all the
like
time.
that.
Parents are always like that. But I use my 7-year-old as an example because he like it's funny making fun of him because he just does awkward stuff. You know what I'm saying?
Yeah.
Yeah.
Absolutely.
I love it when he does awkward stuff sometimes.
So you like making fun of me?
No, I don't keep you kidding.
Making fun of people is bullying.
No, it's not a true statement.
Verbal bullying versus physical bullying.
Depends how the person takes it.
Yeah, that's not a true statement entirely.
Not entirely, but
I like you. You like me?
yeah.
Hey, so it's not bullying.
But that's only sometimes. Like, sometimes you like me, sometimes you don't.
It's like you're picking
It's not that I don't like you. Jay, I like you. You're a good kid. It's just sometimes you have your moments. You know what I'm saying?
That's what
I don't
I'm
like
saying.
your
Sometimes
I don't like your moments.
we don't like each other, but sometimes we do.
I don't like the moments. It's like Ace Maddox, my son. I don't like his
pretty funny,
moments.
actually. You think my moments are not necessary, but I think I'm pretty funny. That's a good lie.
All right, let's talk about this real quick. We can get through this pretty quick. Now, make sure you listen and pay attention. As you put your phone away, I'm going to take it from you. Okay? Thought we were pretty clear about that. Okay, this can get a little dicey. All right, so just listen. If you have questions, make sure that you ask them so that I can help you get it figured out. All right. Other than that, if you gain a pretty good understanding of the basics of it, then it makes the rest of it pretty easy. Okay. There is a way that you can find some of this information on your calculator. Okay, and I will show you how to do that tomorrow. Everybody good with that? Today we're just going to basically get the basics down of this and how to interpret the data. This is all statistics. Okay, so what are we going to be dealing with? Something that you guys have dealt with before, which is what? Mean, median, and mode. All right. So what you have to determine is what kind of distribution we're dealing with. And in this case, it's going to be what? So highlight that. Take your pencil, circle it, put whatever you need to put around it, and just okay, this is normal distribution. Okay, because so you're going to have a normal bell curve. Okay, some characteristics of a normal bell curve is that first of all, it's continuous. It is bell-shaped and it's symmetric. What does it mean by symmetric? Yeah, same size. They're equal on the same side, right? It's like you're symmetrical. Okay? With respect to the mean being the average, or okay, in this case, what you have to understand is that when we deal with bell curves, the mean, median, and mode are one and the same. Is everybody with me? Okay, it's all the same. And it's located in the very center, right here. Everybody see that? Okay. The third thing is the curve approaches but never touches the x-axis. It's never going to touch. It's just going to sit right on top. Okay? What you have to understand about that is this. If you notice, you go from here to here, right? That's one deviation. Everybody watch this. Pay attention. That part right there is one deviation, right? From here to here is one deviation. Okay, now, if you notice out here on the very end of the tail, okay, you don't see another notch out there, do you? Okay, well, there is one out there that's equal distance of these two. You see what I'm saying? So there's going to be out here at the very end, there's going to be a whole bunch of, not a whole bunch, but a little bit of space out there. Is everybody with me? Okay, so that space out there is about that space out there is about 0.2%. Write that down. And it's the same on both sides. Okay, so from about right here to here, from about right there to, oh, it just keeps on going and going and going. Okay, so it represents about 2%, maybe even a little bit less. Okay, but I'm just going to round up to 0.2. Is everybody with me right there? Okay, so make sure you have that written over there and that written over there. Okay, that's essentially going to be 4, this space out here is essentially 4 deviations from the mean. Does that make sense? Let's go 1, 2, 3, and 4. All right, so now the next thing that you have to understand here, okay, is that this area, all of this underneath here, okay, is going to be equal to 1 or 100%. Even though it never crosses the x-axis, it's still going to be 100% of the value. Is everybody with me? Hello?
Yes.
Are you guys paying attention? Okay, you better, because you're going to be lost, and this is pretty simple stuff, or it can be. Okay, now, coming back. We already saw that. Hopefully you took notes on that. Okay, so what we need to, a couple other things, is that approximately 68% of the data falls between 1 deviation of the mean. This little symbol right here, okay, is, write this down. Kind of like an O with a little squiggly. That stands for standard deviation. I think it's written right here. So you can highlight it. Okay, that's the little symbol right there. That's very important. You need to know that.
Okay.
Because I'm going to give you a formula tomorrow. You're going to need to know where to get that number at. The mean is going to be, looks like a little U, okay, with an extended tail on the left side. Okay. 68%, where does that come from? Well, that's this area right here. That's the 34 and the 34 constitutes 68% of the data, or 1 deviation, left or right. Okay? Approximately 95% is going to be this right here, and the middle part. And then if you notice here, 99.7% of the data falls between, and it's not there, there and there. Now if you notice, you got some left over, don't you?
The 0.3.
That's the 0.2. It's like way, it just keeps going, But it gets so small, some of the numbers that you're dealing with are like minuscule, almost non-existent. Is everybody with me so far? Okay, moving on. Okay, so here's how we take the data and work with it. It's normal distribution, which means what?
It means a continuous
Gotta have-
symmetric bell shape.
Good. You gotta have a standard bell shape, right? It's not gonna be skewed to the right or skewed to the left. Everything's gonna be in the middle. Okay, so it's standard. Okay, or it's normal. And you're gonna be symmetrical. When you see the word normal, it just means it's symmetrical on both sides. Okay, so when I can start looking at data here, and I know that what's going on. Okay, so if I have a mean of 45.1%, where does that go? Where's the mean go? Right in the middle. So what I like to do is just write it on the very top. Okay? I write on the top because that's where the biggest part of my pump is, right? Okay? And the standard deviation of 9.6. So what's this value right here going to be?
9.6.
Nope.
Over negative.
Look at this. You take these mean and you add
13.5.
9.6.
Do 13.5.
So I'm going to take 45.
I'm
I'm going to show you. 45.1 and you add 9.6 to it.
So you get
that marker.
What you get?
54.
0.7.
Okay, so that value there is 54.7. Okay? If you look at this line, it's going to be the mean minus one deviation. So it's going to be 45.1 minus 9.6, which is what? 5? 36.5 is this line right here.
And then, what about the other ones?
Okay, then you got to keep going.
And then do you subtract those numbers from 9.6?
Okay, so this next line, it's still a standard deviation 9.6, right? But do I add it to this number or this number? I add it to this number. So that's going to be 64.3.
So on the right, you always add.
You add. It tells you right here. I'm going to add. Okay? Now, it says 2 deviation here, right? But that's only if I start with 45. I'm adding 2 9.6s, right? That's this area right here is 9.6. That's how far it is. Listen to what I'm saying. You guys pay attention. That's how far it is. Okay, so this would be from here to here would be another 9.6. Well, that's where the 2 comes in. You got 1, 2 of them. If I'm going to do at the very end, then I would do 3 9.6. So there's 2 ways you can get around to that.
So you just add 9.6 to the 54.7.
That's it. Okay, now if I'm going to do this one though,
You got
Yeah,
to
it's
subtract
36.
9.6.
from
36.5.
good, so 36.5 minus 9.6, what's that value going to be?
Well, that one is gonna be
29.1.
Do it on your calculator. It's not 0.1. Do it on your calculator for me.
28.9.
26.9. Okay. All right. So now once I know those values, I want to find the value that represents the middle 99.7% of the distribution. Okay, we said 99.7 early on is going from where? From this line to this line. Okay, so the values are going to be this and that right there. Hello, is everybody with me? So what would my answer be right here? How would I write it though? What's my load number?
26.9.
Okay, so I'm going to start with that. And I want to include all this space, all that distance between those 2 marks, right? Okay, so a number here and a number here. How many inequalities am I going to have? I got 2 values I need 2. Less than. What goes in the middle?
One of the numbers.
No. Got all these numbers in the middle. Do we know what they are? Okay? But I know the furthest number to the left is going to be what?
26.9.
Okay. The furthest number to the right?
64.3.
So on those inequalities, do we, if there's a line underneath it?
Not when you're talking about percentage, okay? You're okay right there. If you put the lines under, I necessarily wouldn't count it wrong, okay? But you don't need to. So that answers the question. That's the middle 99.7% of the distribution. Is everybody with me? You guys got this written down?
Yes.
Because I feel like I'm losing some of you. All right. That's pretty easy, right? To me it is. Okay, look at this one. Normal distribution has a mean of 45.1, standard deviation 9.6. So it's the same as the one before it, right? Okay, so now, what percent, I found the low end and the high end. Now I want to find the percent of the data that's greater than, so it's going to be greater than what?
54.
Okay, so we got to find out where 54.7 is on this bell curve, right?
Yep.
Now, I can save you some time. You guys interested in that?
Yeah.
Yeah, I like
What's your mean?
45.1.
45.1. Okay, so now, is 54.7 higher than that or lower than that?
It's lower. I mean,
it's
higher.
definitely higher.
Okay, so if it's higher, which side is it going to be on?
Right.
It's going to be on that side, right? Okay, so what did you guys say the next number was here? That was 54.7. What was the next number? Huh?
64.3.
Okay. I don't necessarily need to know that number though, do I? I can go ahead and stop. I can go ahead and stop right here with that number.
Why?
Well, because it's greater than.
Oh.
Okay, so now, what part of the bell curve is that going to represent? It's from this line to go all the area to the right of it, or all the area to the left of it?
What?
To the right. To the right.
To the right, because it's
Greater than.
greater than that number. So that means that this is what? The lowest number. Everybody clear on that?
Yeah.
Okay, so I want to include all that space that keeps going to the right. Those tails, that tail right there. So now, I'm looking for a percentage, aren't I? Okay, so that's going to be 13.5%. And then my 2.35. And now, here's where it gets tricky, and this is where everybody makes a mistake. Hello, you guys with me?
Yes.
I also have to include what?
I don't know. I don't even know what you got
The 0.2, right?
Where'd you get the 2 point? Never mind. Let's get it now.
I got to include the 0.2 that's way out here, in that area.
It's always no.
They just don't show it because what happens out here. The line is so close to the x-axis, you can't hardly see it.
Yeah.
Is everybody with me?
Yeah.
I still have to include it in my total here. So 5, 8, 10.
And that's our answer.
That's about 16%. % is going to include all the numbers that are greater than 54.7. Everybody okay so far? Okay. Let's see if we can answer one real quick. And I'm pretty sure I included one of these bell curves on each one of these problems, right? Okay, so how does it mean? And you're going to have to figure what each of your values are. So that's 38.5. My deviation is what? Okay, so 38.3 minus 5.9, that will be that value there.
You said minus 5.9? Or add?
I'm sorry, add there and then subtract on the left. Yeah. once you label your parts now, I'm gonna ask you to help me label my parts up here, okay? Now again, let's think smart, not hard here, right? What do I mean by that? What's my mean, guys?
38.3.
38.30, right? Okay, and I want to be less than what?
26.5.
So do I need to work the right side?
No.
I don't, do I? I just need to work the,
Left side.
okay, so what's this right here?
26.5.
Okay, so I want to include, all of that extended out, right? Or no?
How would it calculate?
Why not?
The next one would be 32.4 and then
Yes.
26.5.
Okay, so somebody told me wrong, right? Okay, so that would be what?
32, 34.
And then this would be,
26.5.
huh?
That next one is 26.5.
Okay, so I need to include from this line, all of that, right? Okay, so that's gonna be what? Anybody have an answer for that yet? What's the percent of data that represents less than 26.5?
2.35.
Well, no, plus,
Plus
because 2.35, is that one of my answer choices? So what do I gotta add? Okay, now, understand it's approximation too, right? So can I round down and round up? Right, so my answer's gonna be, okay,
So even if it does say less than, like if, like it says less than 26.5, I thought I had to like subtract 2.35 from this point, 2. Do you just add everything?
it's 13.5.
No, I'm saying, like, it says that it's less than, so I just assume that, you have to subtract 2.35 and the 0.2, because it says less than instead of, more than.
Yeah, but we're not, I think if I understand what you're asking, we're not worried about minus or plus. Is that, if you're gonna, the left side goes down. Does that make sense? Think of it like test scores. Like if we tested everybody, and we said that the average score, or the person, everybody have, let's say 5 or 6 people scored 80 on the test. So that would be the mode, right? But it'd also be the median and the mean, right? So 80% would be there, right? They scored 8 out of 10. You see what I'm saying? All the scores on this side would be what? Less than 80%, right? Okay? All the better scores would be that way. Okay? But I'm just trying to find this number right here because that represents this area right here. Does that help?
That's not really what I asked, but yeah.
Well, I'm confused about your
No,
question.
I understand now.
I'll try. All right. Packaging. Students counted the number of candies in 100 small packages. So you got 100 packages of, let's say, Reese's Pieces. All right?
Oh, we're doing more? I thought we
Hey.
were doing half today.
I said example 2.
Oh.
Doing 2 examples. They found that the number of candies per package was normally distributed. Is this important? You know that?
No.
This right here. Is that important to know? Yeah, because it tells me what type of bell curve, right? It's gonna be symmetrical, it's gonna go, the hump is gonna be in the middle. It's got a mean of 23. Okay, package and standard deviation of one piece of candy. What does that mean? Some bags could have 22, some could have 24, give or take, right? Okay. About how many of these are going to have between 22 and 24 candies? Okay, so what goes in the middle? 23 is here, right? Next line there is 24. The next line going to the left would be 22. So what area am I looking for?
The middle.
The middle. Okay, here's, guys, listen, watch now, pay attention. That's this part right here. Okay, now, is it asking you for a percentage? Colin, are you with us? You kind of look like you're not with us. Is it asking for a percentage? Okay, it's asking for how many packages, right? Okay, now the good thing is we're working with how many? 100. Right? So, what is this area and this area accounts for 68%, and you guys know that that's like saying writing it over 100, right? It's the same thing. So now the percent actually just basically turns into 68 packages, right? 68 of the 100 packages could potentially have either one fewer or one more than the standard. Does that make sense? Okay. Look at this one. Again, the same thing. Got 100 small packages. It's just basically kind of the same problem. They're just going to ask something different. Normally distributed. My mean is the same. My standard deviation is still the same. Okay, now we want to know the probability, right?
Can you go back to that last slide?
Now, let me finish this first, okay?
Alright.
Now we want to know the probability that more than 25, that one of the packages, Logan, you need to wake up and pay attention. Okay, that means open your eyes, right? Notes down. Okay? Some of these packages are going to contain 25 or more, right? Okay, so what was my middle?
23.
Okay, and then this was 24, that would be 25. So how many packages, or what's the probability, or the percentage, that I may get a package that has 25 or more? It's going to be this area right here, right? Which is what? 2.5%. A good thing you woke up for that, other than the easy one you missed.
How did we get 2.5? You added a 0.2 to the
25 or more.
There's always two, there's always two.
You see what I'm saying?
Yeah, I see that.
Okay, 25 is there, which worth more than 25. It's going to have to be to the right.
Would be the 2.35 plus the
0.2.
2.5.
5.
Rounds up.
Just go with 2.5.
That's
DJ?
the last slide. I'm sorry,
That's okay.
didn't see it all. Okay, why do we have the 68% because of 34 plus 34? Okay, that's fine.
That accounts for 60, between there is 68%. Now the nice thing is I'm working with 100 packages, right? Well, how can I write 68%? It's just like writing the 68 over 100.
Yeah.
Well, so if I have 100 packages, 68% of those could be considered 68%. Okay?
I didn't get that.
Okay, answer this one real quick. Did you get this one, Ryan? Pretty easy, right? Anybody else?
Hold on. Oh.
Pretty easy, right? Go see it. Did you get it? Did you get the same thing he got? Anybody else? Chris, did you get it?
Okay, yeah. That should be 20 assumption. Hold on, I know that wrong.
You get it? No? Well, you gotta make sure your deviations are fine, because that's what Crystal messed up on. What's the first one? What's the main?
26. You put it in the middle. And then you go 23, 32 to the right.
Well, what's that gonna be? 29. Because my deviation is 3, isn't it? It's not far from this to that number.
Oh,
From this to that
then
number.
that one's 32. There you go.
Now,
So,
do I need to do the left side?
Yes.
you need to do 30.
Part of it, right?
Just
Okay, so from here to here would be 23. But now I can stop from there. Okay. So we need to go between this one and between that one. Correct?
Okay, it's D. Yeah.
So that includes this area. Okay, so I just now, all I need to do is take these two, which I know is 68, and then add that to it. Right? My answer is going to be okay. Now again, you should have two of these. Okay, you should have a study guide, and you should have a skills practice. Now, here's the reason why. Hold on a second. Here's the reason why I want you to have both of these. Okay, because you can pretty much work this entire page, the study guide. There's a few of what we worked on today. There's a few of those on the skills practice and the practice. You guys with me? Okay, so you go ahead and work those today, but you can get work today. And wait for tomorrow on the other part. and I'll show you how to find the Z values. That's the lowest and the highest. Because sometimes it's going to move around a little bit, right? Okay, so we need to determine what our Z values are. There's a formula for that, and I'll show you how to do that tomorrow. Plus, I will also show you, because my values move, it's going to change my percentages, right? Hello? Like if I go in between, you see what I'm saying? Let me show you real quick. If I go, let's say I go from this to this, well, that space is in between percentages. You see what I'm saying?
Yes.
Okay, so you have a new low and you have a new high. And I'll show you how to plug that into the calculator tomorrow to work that. But if you look at the study guide, it kind of shows you on the study guide if you can decipher that. That's up to you though. Any questions? No. Okay.
Is there a link desk?
Unless it's a station, unless it's close. I need that.
Shine, did you grab one already? It's not hot in here. It's hot. Yeah. This is the first section of our second test.
So we're gonna start already first? I'm sorry,
Rather you kill me. No, this is just an assignment for this section. Okay. It's not an overall. Okay. That comes to that when we get done with the unit.
can I come in Monday and do my test?
Yeah, I mean, if you want to. Unless you did pretty good the first time.
I got something.
You already got one. Where's it? Got 2 regular tests and 1 block exam. The block exam is how much you grade. So it only is going to like 2 to 3 at the most points. Either way. Let's say, for example, these 2 tests that we take, and your average is 70, and on the block exam you score 70. Is your grade going to change? No. You see what I'm saying? Let's say if you got a 90 though, okay, and you score 60 or 50 on the block exam, what's going to happen to your 90? You're going to lose it. Okay? I don't think you'll fall below a B, but I don't think you'll fall below like 10 points. Okay? But it's, you guys are sitting on the fence like if you have an 81 and you totally bomb the block exam, what's going to happen? You're going to go down to the next letter grade. Yeah. But that was, listen, and I've said this like 4 or 5 times. That's why I made this first test as easy as I could possibly make it. Okay? I included so much Algebra 1 stuff on there, it wasn't even funny. I mean, there's only probably 6 or 7 problems on new materials. But I'm not going to give you a 6-question test. Okay? Why would I not do that? Because if you miss 3, what's going to happen?
You got a 50.
You've got an automatic 50. Well, that's not a fair assessment of your abilities, is it? That's why I put a whole lot of pre-algebra and algebra 1 stuff on that. Stuff that we've been doing. We did in the first semester before Christmas, stuff that you did last year. Huh?
No, it's due Friday.
Yeah, both of them are going to be due Friday.
Tomorrow.
Do you understand what I'm saying? And that's why we took 2 extra days. You need one, Tori. That's why we took a couple extra days to review. Are you with me still, or are you playing on your phone? Okay, you understand that hearing me and paying attention are two different things, right? I hear what my wife is telling me, it doesn't mean I'm paying attention all the time, and she gets mad at me for it. Okay? Because I'm not paying attention. I hear what she's saying, I hear her talking, but I'm thinking about something else.
Stop it.
Here's the second page. Everybody hearing you? 3. Is everybody hearing me? The second page. Practice. You got it already? Do you need it now?
That would be nice, but you don't have to.
Yeah, I could give it to some of it to you now. You know, as much as it's been gone and I've sent home, it's never come back. You know what I'm saying?
Yeah.
That's why I was like, to get it all together, takes a long time. But I'll give you this.
Okay.
This is basically what we've done. I'll give that to you.